problem with 2 taps. So let's begin. 2 rectangular tanks are shown below. We are given tank A and tank B, and we have the length, breadth, and height. At the beginning, tank A was 1/10 filled with water and tank B was 2/5 filled with water. So we are given fractions. Let's underline. So we can also see from the figure that tank A is 1/10 filled and tank B is 2/5 filled. Let's continue. Both tanks had taps turned on at the same time, and water flowed from both taps at the same rate of 1.2 liters per minute. We are given the rate, so let's underline this important point. Part A asks, how long will it take for the height of the water to be the same in both tanks? And part B, at what height will this happen? So let's break this question down and let's solve it together. So let's start with part A. So we are given that tank A is 1/10 filled, tank B is 2/5 filled. So firstly, can we find the height of the water in both tanks? What is the height of the water in tank A? It will be 1/10 times 40 gives 4 centimeters, which is over here in our figure. And what is the height of the water in tank B? It will be 2/5 times 35, which gives us 14 centimeters over here in our figure. And now, since the question is asking, how long will it take for the height of the water to be the same in both tanks? Let's understand this clearly with an animation. So these are the front faces of tank A and tank B. So firstly, we can see that this is 4 centimeters and this is 14 centimeters. So what is the difference in height in both tanks? It is 14 minus 4, which gives us 10 centimeters. So for both of the tanks to reach the same height in the same duration, which tank will need to fill up faster? It will be tank A. And here is the animation. Yes, so they fill up to the same height. And if we look at the increase in height of A compared to the increase in height of B, what is their difference? It is actually 10 centimeters. So this will mean that tank A will need to fill up faster per unit time in order to fill up the extra 10 centimeters. So we will need to find the increase of height for both tank A and tank B per unit time. And in this case, it will be 1 minute. So let's take a look at our question again. So here is the difference that we have found. And the question gave us the rate of 1.2 liters per minute. So this will mean that in 1 minute, there is 1.2 liters of water coming out. So what is this in centimeter cube? It will be 1,200 centimeter cube per minute. And since they both have the same rate, they will both increase by 1,200 centimeters cube in 1 minute. So first, let's focus on one of the tanks, tank A. So when the tap is on, for every minute, 1,200 volume of water will be added to the tank. And what will be this increase in height? How can we find height from volume? We can take volume divided by base area, and that will give us the height. Are we able to find the base area of A? Yes, because we have the length and the breadth. So the base area of A will be 60 times 10, which gives us 600 centimeters squared. And now, how can we find the height increase in 1 minute for A? It will be 1,200 divided by 600, and that gives us 2 centimeters per minute. So this will mean that for every minute, 2 centimeters of water are added to tank A. And now we can do the same for tank B. So what is the base area of tank B? It will be 50 times 20, which gives us 1,000. And we can find B's height increase by taking 1,200 divided by 1,000, which gives us 1.2 centimeters per minute. So for B, for every minute increases by 1.2 centimeters. Alright, now let's find the difference in the height increase per unit time. So how can we find this? It will just be 2 minus 1.2 and that gives us 0.8 centimeters per minute. And now, to find the time that it will take to reach the same height, we can just take the original difference in height divided by the height difference per unit time. And that will give us 12.5 minutes. And we have our answer for part A. So if everyone has understood, let's move on to part B. At what height will this happen? So we have the height increase of A and the height increase of B. And with our previous answer of 12.5 minutes, we can take 12.5 minutes times 2 centimeters per minute, which gives us 25 centimeters. And this is the height increase for A. And don't forget, we will need to add the original height of 4 centimeters. And that will give us 29 centimeters. Of course, we can find B's height increase in 12.5 minutes as well. And we will still get the same answer in the end. Alright, so we have come to the end of this question. Let's summarize so that you will be able to do questions like these by yourself. So this is known as the two taps problem. We have volume and rate. And remember, we needed to find height from volume. And what was the formula? It was volume divided by base area. So this question gave us the volume and the base area. So we were able to find height. But in other questions, if we were given the height and the volume, we can find the base area. This is known as know two, get one. If you know either two, you will be able to get the other one. And remember, for part A, we wanted to find the time taken for the height in both tanks to reach the same height in the same duration. So we took 10 centimeters, the original height difference, divided by the height difference per unit time. So this is how we can find the time taken. So to achieve the same height while both tanks are increasing, we can find the time by taking the original height difference divided by the height difference per unit time. And that is all for our question. If you have any other questions regarding PSLE, feel free to scan this WhatsApp QR code to join our PSLE study group. And with that, don't forget to subscribe. I'm Teacher Pamlin and I'll see you in the next video. Bye bye!